Chromatography is a very useful technique for engineers, but mostly for chemical engineers and biochemical engineers. For chemical engineers, chromatography helps them find out more information about the gases in a gaseous environment. For biochemical engineers, chromatography is essential for protein synthesis and protein investigation. Today I'm going to talk about gas chromatography. Gas chromatography is used to analyze samples. All samples must be volatile because they have to vaporize in the oven. Now let's go through the 5 main components of a gas chromatograph. The first main component is a carrier gas. Carrier gas can either be helium, hydrogen, nitrogen, or argon. These 4 gases are really stable and non-reactive, so they don't react with a stationary phase. I also want to mention that carrier gases are the mobile phase in this case. The carrier gas has to go through this tube from the valve in the sampler, which is the place where we inject our gas or liquid. If it's a liquid, we have to stay in the range of 2 to 3 microliters. In the sampler, this liquid is injected, it vaporizes immediately because the temperature is really high. After the sampler, it goes through the oven. The oven can reach up to 400 degrees Celsius and it contains a column. The time it takes for a gas to go from one point of the detector to another, it's called a retention time. In the column, we have a non-polar stationary phase. Let me show you the picture. We have a non-polar stationary phase and 2 gases. So this is stationary phase and these are the 2 gases. A non-polar gas and a polar gas. The non-polar gas is going to stick in the stationary phase for a longer time compared to the polar gas because the non-polar gas is soluble in the non-polar stationary phase. If the non-polar gas stays more time in the stationary phase compared to the polar gas, which is going to be carried out in the column by the mobile phase, so the retention time of the non-polar gas is going to be longer. So we can see the 2 peaks in this graph called a chromatogram. This is the graph of abundance over retention time. If we analyze the graph, we can find that the non-polar gas represents the highest peak, whereas the polar graph represents the peak with the smallest height. I also want to mention that the area in these peaks represents a concentration of each gas in the mixture. Thank you.